Mic check. Okay. Hi, baby doll. Good evening or afternoon, whatever you think of it as. Hello, little peeper. I think of it as evening because it's starting to get dark these days. Glazer's here, first killer. Good evening to everybody. So we're in week 6, which means that the semester is kind of racing along at a pretty good clip these days. Apologies if my voice is a little ragged today, so I've got tea and honey, but if I clear my throat a little bit more, if I have to do a big throat clearing, I'll mute. But we'll see. Right now it seems better than it did earlier today when I did a class. Okay, so we are in week 6. Hopefully most of you, or all of you, it would be terrific if all of you had started and were very far along in your first individual project, but just to remind you, that's due on Sunday this week. So don't let that one go too long. We have a very good Piazza discussion group for our class. And you have a couple of rockstar question answers among you, so don't waste that as a resource. I would argue that every time I answer someone's question, especially if it's a slightly different problem than I've seen before, that I have a chance to learn something. So if you ask a question, you're giving someone else a chance to both feel good about themselves for helping you and probably to learn something in the process. Good evening, Tyler. So don't forget that it's due on Sunday and it's 500 points, so the stakes are high. You can turn in partially completed projects, but they have to compile. So if you find that you can't get all of the features, but you still want to get some of the points, make sure that whatever you submit runs, that it doesn't show compiler errors. So it may mean that you have to comment things out or delete things if you're only partially completed, but you can turn in partially completed work. Okay, so we're actually, tonight I'm starting on the next phase of the class, so everything that you need for the first individual project we've already discussed. So tonight I'm actually moving on to techniques that you're going to want for future projects. And we're going to use, by the way, this same file reading and command line argument stuff for the whole rest of the semester. So the time to get comfortable with this, and if it requires some practice when you get past the first project, make time to practice it. I'll show you a couple of examples of how I might practice it. But you want to get it straight in your head. You want to have a good mental model of what's going on with command line arguments and with handling file inputs. So you're going to like it, I think. Most of you up to this point in your programming careers have done a lot of interactive programs, and by that I mean you print out prompts for input, please enter a number now, and then you handle keyboard inputs, and that's how a lot of the data sort of flows into your program, is by someone typing answers at the keyboard. So we're going to get rid of a lot of that, and we're going to start using files to pump data into our programs. The nice thing about that is that once you have a program built, all you have to do is change the file to change the data that you pump into your program. And you can also then create small or large or medium-sized files so that you can send any amount of data that you want into your program. I'll show you examples of that as well. So I'm going to do this. I showed command line arguments first, but I'm actually going to do the file input part first. So let's deal with that. And I want to introduce this week an online documentation resource. So if you don't feel comfortable doing what I'm about to do just yet, that's fine. But the sooner that you go look at this documentation and get comfortable with looking up things in it, the more powerful you will become. So it's at c++.com. It's not perfect, but it's pretty good. So c++.com, it even has tutorials. I don't think they're the greatest, but there's something if you want to learn something new. There's a bunch of tutorials. For us, it's the library references that we're interested in, so all of this stuff. But they have articles. They have additional information about C++. But it's a really easy site to use because you just type in what you're interested in the search field, and it takes you right to the stuff. So we are interested in file streams. So that's F stream. That word stream should be familiar to you because you have included IO stream, you have included S stream for string streams, and now tonight we're going to start including F stream for file streams. The concept of a stream is a little bit tricky to get comfortable with, but when you see that word in C++, what should enter your head is some of the same techniques I've used with other streams are going to work. So if you're writing data to a file, for example, and you have floating point data that you want to write into a file, if you want to format that data, you use the magic formula, just like you use with string streams, just like you use with IO streams. So that's usually good news when we see a stream because we think, oh, I already have a sense of what it might be able to do. So we're going to be streaming data. In this case, we're going to be streaming data into our program from a file. So I'm going to go look up fstream just to get us used to reading the documentation. So when you're looking around C++.com, usually at the top of these files, when you're looking, let's see if I can highlight it without that happening, it'll tell you what include you're going to need to get the thing that you want. So if you wanted fstream, you would have to include fstream. So it's actually telling you in its documentation what it is that you would include. There's a lot of scary stuff down here, all these flags and state, a whole bunch of other stuff. But there's also, and we've talked about this now, lists of public member functions. A public member function is a function you can use if you have an instance of an fstream. And it's actually got several different sets of public member functions. We haven't talked about inheritance yet, but basically all the functions down here are available for you to use with file streams. I'll just highlight a couple. We're going to use isOpen. We're going to use close, wherever close is, there's close. And we're also going to use this, what's called the extraction operator, to extract data from a file. That's most of what we're going to need. But anyway, I wanted to get us used to reading this documentation. Now more specifically, we're actually going to use an input file stream. So we want files to get input data. So IF stream is more specifically what we're going to want. So we want IF stream. Notice it's the same include, which I'm having trouble highlighting it because everything lights up. It's the same include, F stream. And you'll notice for the most part it has all the same functions. So that's good news. So now I'll show you a real simple example of how to use it over in Replit. So I'm going to go ahead into Replit. I'm going to create I'm going to call it Lab 6, but I'm actually just going to do some sample code first before I do anything with the Lab 6 stuff. So I'm going to use the plus this time, C++, and I'll call it. If ever I see a name that's random that I really, really love, I'll probably leave it, but Lab 6, I didn't like that name that it gave me. Okay, so here we are, Lab 6. We'll go ahead and leave IOStream here, but let's add fstream so we can use file streams, and I'm also going to add the using directive so that I don't have to do any of this stuff. Okay, so we're going to do file streams. Now, to do a file stream, what it means is that you intend to be either writing data out to a file or reading data in from a file. We're actually going to be reading data in from a file, and to do that, I'm going to go make a file. So I'm going to add a file. I'm going to call it, let's call it movies. Let's do a movie one. .txt. Now the reason I put .txt on here, which is actually not required, but I want to make it clear to you and to me when I come back that this is not code. This is just plain text data. That's all it is. It's a file with text in it. It's not code. It doesn't get compiled. It's just a place to put information in plain text. So no code goes in here. We'll just put movies, right? I'm trying to remember. Tyler gave me some. Frozen was one. Let's go Disney. Jumanji was another. I remember. Can someone hit me up with like 3 more? Probably is enough. Actually, just 1 more. Cars. Thank you. Okay. So there's my movies. So that's all that is data. Just in plain text. So now let's go write the code that allows us to read in the data from that file. I don't need this C out. So the way to do that is to create an input file stream. I usually call it fin for file input, but you can call it the file, you can call it the file input, you could call it movie file, whatever, right? So it's the same. So that's a good question. So the question is there a different input-output stream for CSV files? And the answer is no, it's exactly the same. In fact, that's I'll use your idea. So we'll turn movies into a CSV file, and then we'll process the data from it. So that's perfect. So the answer is no, it's not a different file stream. It's the same if you're using a comma-separated values file, or really anything that shows up in plain text. Good question. Okay, so that's the class, that's the type, and this is the instance. It has an overloaded constructor, so hopefully you recognize this. It has an overloaded constructor that allows you to specify what file it is you intend to read as input. So I want to read the movies file that's in here as my input. So the name of my stream is fin, file in. Its type is an input file stream, and then I've used the overloaded constructor to tell it that I want to connect up to the movies.txt file. Okay, and then you need to be in this habit when you're doing file inputs. Even though I can see that the stinking file is right here, it's just best practice in case you make a typo or in case something happens to the file. It's always best practice immediately after you create your file input stream to check to make sure that you got it. So this is that is open function, but what's supposed to happen is this is supposed to try to connect to and open the file for input. So I immediately check to make sure that that happened. You should just always do that. I could have accidentally misspelled the file name, I might accidentally delete it. Any number of things can happen to the file system could become corrupt. So whenever you set up to process an input file, immediately check to make sure that you actually got it opened before you try to do anything. And what I usually do is I actually put an else here so that I can print out a message for myself that says something like unable to open movies.txt. So if something goes wrong, I'll see it. In fact, let's make something go wrong. Let's call it OVs. MVs. That's an easy typo to make, I would think. So let's run that, and what should happen, since that file doesn't exist, is it should trigger my else part. So this is going to try to connect to and open it. Then it's going to check to see if it's open. That's going to fail because that file doesn't even exist, and I'll get an error message. So there's the unable to open. So when you're doing file inputs, a little bit of extra paranoia is always a good idea. You already know that about users typing at the keyboard, right? That you should always be a little bit paranoid that they're either making mistakes by accident because they're not paying attention, or they're making mistakes on purpose to see what they can break. So the same kind of goes for files. You have a little bit of paranoia here about actually getting it open. Okay, so if we get to this if, which I always have trouble getting it to click. If we get into this if section, I'll separate it out a little bit. Then we know we've got the file open, and now we can read it in. So here's the way I like to do it. If you go look at Stack Overflow or any of the other places where you might look for ideas about how to read data from a file, there's a whole bunch of different ways to do this. Just like everything else in C++, there's a whole bunch of different ways to do everything. So I have a particular way that I do it in part for teaching purposes, but I also think it's very repeatable. It's sort of an easy pattern to copy whenever you need to do a new kind of file reading operation. So here's how it works. We're going to read each line of the file, the whole line at a time, as a string. So I make myself a string. I'm going to need an include for that, probably. So the file's open, but I haven't started reading its contents yet. But to read its contents, I need somewhere to place the contents as I'm reading it line by line by line. So I'm going to use this variable, next line. I'm going to read a line, put it in there, print it out, read the next line, put it in there, print it out, and so on. And here's that operator. So it looks like this. While I can extract, actually let's not do it that way. Let's say while getLine. Okay, so what this code means is I'm going to read entire lines. That's what getLine means. I'm going to read the whole line up to the next new line character or line break from this input file and store what I read, what I get, into this string. So get a whole line up to the line break from this input file, store that line that I get into this string. Placing it in a while loop, so what happens eventually is getLine finds no more data, and that causes the loop to break. So as long as I'm still getting more lines of text, this will work, and the moment that it runs out of lines of text, in other words, it hits the bottom of the file, it'll kick itself out of this loop. The one thing that you can't see happening here is how do I know it goes to the next line and then the next line? That's automatic. So getLine automatically advances in the file to the next line down. Every time you use getLine, it will get the current line and then automatically advance to the next line down, waiting to see if you want to read it. So we're going to read them all. And I'm just going to say, got another line. So what should happen is got another line for each of my movies. That's pretty much it. It's not a bad idea also to do a, once you're done with your processing, close the file. You don't in every situation need to do that, but it doesn't hurt to manually close it once you've done reading its contents. So the thing that people get confused about here sometimes is, like, where is all the, like, am I loading the file into the program? You're not. What you're doing is you're reading characters from the file into this string, and now it's in the program. So it's going to read it into this next line string, print it out, and then it's going to overwrite the next line string with the next line in the file. You're not actually affecting the file itself in this case at all. You're just reading the raw data from it. Alright, so let's run that. It's going to show us the three movies that we had. So Frozen, Jumanji, and Cars, because it read the three lines of the file. So I'm going to go add some things. I'm going to put a blank line in here. I'm going to put another one. Alright, Frozen, Jumanji, Cars. What's the, oh, is it Mermaids? Is that, I don't know if that's Disney or not. I could get in trouble with the Disney people I get the wrong. Okay, Mulan. Oh yeah, we did Mulan. Okay, so all I've done is change the file. And I'm going to rerun the program. I'm not going to touch the code. There's no reason to do that. I'm just going to change the source data in the text file. That's it. And then you'll see there's the lines, including the blank one, which is something that sometimes you want to look for and deal with. So that is a basic file reading loop. It's pretty simple. So you can do things like this in your file reading loop. While you are reading in lines of the file, you can look at them. So you could say, for example, did I type that? I did. Okay, so while you're reading the file, you can be checking the lines for things like if they're empty or not. So what I've done now is I've put an if statement inside of here, and only the non-empty lines am I going to pay attention to. So if it's an empty line that I just read, I'm going to ignore it. And of course what's going to happen is the blank line goes away because I just ignored it. You can also do things like this. You can put special lines in here. There's another blank, by the way, but I could say this is a database of Disney movies. So I'm changing the source data. Now I am going to change the code because what I want to do is ignore these comments. And what I'm doing here, I just made this up, but it's not uncommon. I use the hash symbol to mean comment. So if there's a hash symbol or if the line is empty, I want to ignore those lines and just pay attention to the lines that have actual movie data on them. So that's a change to the source data. If I go back to the I could just add another condition here. So non-empty lines and lines that don't have this hash symbol as their first character. So this next line, .@0, that's checking that string at position 0, which is the first position, just like an array. So the first, if the string is non-empty from the file and its first character is not a hash sign, then I'll pay attention to it. So I'm ignoring empty lines and I am ignoring comments. So there you notice it's just the movie lines and not any of the others. It is reading them, but I have written logic to ignore the special ones, the empties and the comments. So still, I think, pretty easy. I hope that you agree that that doesn't seem all that bad yet, and it's not. Okay, so let's go change the source data and then make this a little bit more challenging. So I'm going to use the comma-separated values style. And when we say comma-separated values, we mean fields of data separated by commas, right? So Frozen, which is a Disney movie. I could use IMDb for that. Let's see what IMDb has. Sorry, it's a little obsession of mine to actually get actual data when I can. Frozen. What genre did they put it in? Where's the genre listing? Well, oh, animation, adventure, comedy. Okay. I'm not going to spend too much time on that, but let's say adventure movie, and let's just give it a rating for fun. And I actually haven't seen any of these, so my ratings are made up. Jumanji, let's call that a horror. Cars, which is probably a comedy. And Mulan, which is also an adventure movie, which I haven't seen, but I'm making up the ratings. So this is an example of a comma-separated values file. And it creates a new challenge because it has, each line is now not just one piece of data, but 3 pieces of data. Hopefully it makes sense to everyone, by the way, that all 3 of those pieces of data are about the movie Frozen. So it's an adventure movie, and its rating that Boyd just made up is 4.5. Jumanji is a horror movie, and its rating that Boyd just made up is 4.6, and so on. So if we run this, I don't need to change the code yet, I'll just run it again. So now we're seeing we're getting the whole lines. Now, in programming, the real action is taking this data apart and putting the data into the right types of variables. We call this process, by the way, modeling. So I'm going to model, M-O-D-E-L. I'm going to model this movie data in my code. Since there's 3 fields of data for each movie, I'm going to use a struct for that. I could also use a class, but let's start with the struct. So what is the data for a movie? How do we model in software a movie? Well, we have a title, we have a genre, and we have a rating. I'm going to use doubles. Rating. So now I set up a template, right? A model, as we call it in programming, to represent a movie. And hopefully everyone kind of sees that I've built my model based on the input data that I have. My input data is movies, and each line has 3 fields, a title, a genre, and a rating. So when I'm modeling for that data, I created a struct called movie that will contain a title, a genre, and a rating. So the catch now, the hard part, is that we have to bust the pieces apart. So we'd have to take the lines that are movie data and get the 3 pieces apart and use them to populate a movie struct. So I'm going to start by taking the pieces apart. There's 3 pieces. So I have a title, I have a genre, and I have a rating. Now these are separate from the struct. The reason why I have these here is because temporarily what I want to do is see if I can get those pieces out of the file and put them into the correct kinds of variables. So this next part's going to look a little bit scary at first, but it's not. So it's just something that you'll practice and then you'll get comfortable with it. So we're going to use another kind of stream. It's going to come from S stream. So the first thing I'm going to do is I'm going to include S stream. So you've used these before. You've used O string streams when you wanted to produce formatted output. But we're actually going to use I string streams this time. And I'm going to call it my parser. So I'm using an input string stream this time that I'm going to refer to as parser. So this part's going to seem a little complicated, and hopefully when I go back and sort of tear down the steps, it won't seem quite so intimidating. So hopefully everyone knows what we're doing now. We're opening a file. We are checking to make sure that in fact we got it open, because it's wise to do that. And then we have a loop that reads each line of the file into a string. That's it, right? And then we're printing it out. So, and then we added this bit of code that ignores the empty lines and ignores the comments. So once we get into this if, we've got data about a movie in 3 parts, and it's in these 3 parts. But we need to get the parts separated. So separating the parts like this is called parsing. There's other uses for parsing, but I'm going to use it here. So we're going to parse this data, and what I really mean is we're going to split it into its 3 separate components. So every line we get has to be split apart into its 3 separate components. And to do that, we're going to use this parser on it. So I'm using the parser on the line of the file. It's a lot of moving parts here. So I take this line that I read from the file, and I set up a parser for it, which is going to make it super, super easy to tear it to pieces. This is a stream, by the way, so you could go to c++.com and see some of these things in there that I'm about to do. Okay, so this one's going to look funny, but you have to remember, okay, what do I get from the file? I get things that look like this. In fact, I'm going to copy that, and I'm going to put it here next to my parser so I can remember what the format looks like. So it's a title followed by a comma, followed by a genre, followed by a rating. That's what a next line might look like. So I'm going to parse the next line into these three pieces: a title, a genre, and a rating. Alright, so here comes the parsing part. There's the title part. So getLine is going to look familiar because we used it to read an entire line from the file input stream. Now I'm going to use it to get some data from the parser, which is an input string stream. So not an input file stream, but an input string stream. It's a lot of stuff, right? And whatever data I get, I want to store it in my title string. And then there's a third argument that I'm now using. So this third argument, if you add an argument, it overrides the default behavior, which is to read all the way up to the next line break. And what this does instead is say, read up to the next comma and stop. In fact, it doesn't stop. It reads up to the next comma, and then it moves forward waiting for the next parsing activity. So that gives me the title. So I'm going to get line off of it again. This next piece I want to read into the genre. That's the second thing. And I want to stop at the second comma. It is confusing at first. It takes a while to get all these moving pieces straight in your head. Notice this getLine up here off the file stream doesn't have the third argument. It doesn't have a comma, single quotes, anything behind it. So in this format, pardon, getLine will read all the way up to the next line break. In this format, getLine only reads up to the next of that character. So this is how we would parse a comma-separated values file. The last one is a little tricky. Because you cannot do this. I don't need the comma on this last piece because that runs me up to the end of the line. So for the last piece, I can just run off to the end of that line. But there's a problem here. getLine is only built, I don't know why that clicks funny. It's only built to store stuff into strings. So it will not work on doubles. So here's a way to get around that. It's not really getting around, it's just dealing with it. So I'm going to call this the string rating. And I will first read it into a string. I'm going to separate this part out. So read all the way up to the first comma, store whatever you get into title, and then getLine automatically advances the thing to the whatever comes after that comma. Just like getLine on the file advances it to whatever comes after the line break. So I get the title up to the first comma, then I get the genre up to the first comma, and then I get the rest of the line, which I am now calling S rating, because you can only get line on strings. But I want it to be a double, so how do we do that? Well, I say the rating, the double one is string to double, the string form of it. Now we're going to go look at C++ for this. I believe that's correct. We'll find out. So when you are parsing, when you do my style of reading a file, everything is strings. Everything is strings. And when you get down to the point where you actually need something that's not a string, then you're going to have to do some kind of conversion on it. So I'm reading the rating as a string, and then I'm converting the rating as a string to a double. Let's go look at cplus.com and make sure that I'm doing that right. So go up to this search, type STOD. No, STOD. So ATOD is sort of the older form. You want STOD is a little bit more robust. But it's correct. You could use it, but we're going to use the STOD form, which is, see that little C++11 thing? So what Babydoll is pointing out is that if I were using an older standard of C++, STOD wouldn't work. But in Replit, we're actually using, I think, C++17 now. And I never use anything less than C++11. So this is going to be safe, but it is something to pay attention to. Notice how I get it by including string. Well, I've already done that. So no new includes to do. Okay, and then I'm going to print them just as an initial, right? So I'm going to print the title, and then I'm going to change, not a comma, I'm going to change what separates them because I want to see if I actually parsed the data into its separate pieces. I don't want to accidentally print out next line or something that has commas in it because I might forget which is which. So anyway, I'm using space dash space so that I know absolutely for certain this is my parsed data and not the unparsed file data. Genre rating, I'm not doing the magic formula here, but I could. So there is title, genre, rating all busted up into pieces. So let's run that, and we should see there now it's all parsed. So that's not easy. Conceptually, it's not easy to get comfortable with this. You sort of have to look at each step, open the file, read a line, parse a line into its pieces. So the last thing we're going to do is we're actually going to make movies out of it. So I'm going to make a movie out of it. I'm having like a, you know, if you ever get the keyboard tingles in your forearms, it's messing up my typing. Okay, so now I'm going to make a movie of all that data. Title, genre, and rating. So now I've actually parsed the data and I've loaded an instance of my struct with all that data, and then I'm going to use the instance of the struct M, there it is, to fetch the fields out of the struct. So now I want to see, can I take it one more layer, parse the data, put the data into a struct, and then use the struct to actually print the information out. Now it should look exactly the same. I'm just looking to see if it causes an error. So now I parsed the data and I've actually loaded it up into my model. So this looks a lot, by the way, like this week's lab. Hopefully you'll take note of that when you review this later. Let's go change the file and then change our parsing to match. So let's see what that would look like. I don't know the years of these things, but let's say after the rating, we put the year it came out. It's going to take me a second. Now this one I know I can do, so Jumanji, I guess we could guess. We'll do the 1995 one for Jumanji, Cars, and Mulan. We'll do the 20, we're going to, no, we want that, that's 2006. And then do we want the older or the newer Mulan? The animated Mulan is from 1998. That's the one I'm going to go with. Okay, so I've changed the source data, and now I want to go look and see what has to change. A few things have to change. For one, my model has to change because I've added a new field with a new data type, which in this case will be an integer. The reason why you want to put these things, by the way, in the proper data type is because you would typically be doing this so you could do things like which movie has the highest rating or which movie is the oldest. Well, if you don't have numbers being numbers, you can't figure that out. So when you're parsing this data, you want it to be in the right types of variables so that you can actually use those variables to do math and decision making or loops or whatever, right? You can't, if you compare two strings, it's not quite the same if you're trying to figure out which year came first as comparing two integers. Okay, so I've changed the input, the source data, so I need to change the model. So I'm going to go up to the movie here, and I need to change the model because it has, we'll just make it an integer, it doesn't matter. It now has a year in the model. And now we sort of have to think about the parsing job. So let's go down to the parsing job, which is down here. So string title, string genre, we have a string to sort of be the intermediate for the get line, and then the actual double for a rating. So next we will do a string for the year, call it S year, the string form of the year, and then an int to parse it out. Alright, so this part doesn't change. The first field is title, the second field is genre. Now the rating is followed by a comma, so I need to add that for the parsing. I don't change the conversion, that stays the same. But now I have to do one more get line, and this time it's the year. And I don't need the comma here because the year bumps me up against the end of the line. And then I will do an integer year, and there's another one of these, it's called STOI. These can break if you're trying to turn something that's not an integer into a string, but we don't have that problem here. So, but you should note that these conversions can break if you like feed the word hello into string to integer. It can cause an error. Although if you're lucky, you'll get 0. So hopefully everyone followed that. I changed the source data by adding a new field. I changed the model to account for that new field, year, and then I had to change the parsing. So I added a new string and integer parsing pair because the get lines have to go into strings, and then I can do a conversion. Now when I create the struct, I need to tack on the year data. And then I will go ahead and add I will add that to the output just to make sure the data got in there. So there they all are with the years added. Now I did that in part just because I want you to sort of pay attention to the source data and what the fields look like. By the way, what would happen, what would I have to do if I didn't use commas but instead used, oh I don't know, let's use carets. What if I use carets instead of commas in here? And I'll type this while you think about it. What step in my algorithm has to change if I change the commas to carets? Works just as good, but something is going to have to change about my parsing algorithm. Here, I'll bring this up and maybe you can point me to a line and what I have to change about that line. There you go. Good one, Glazer. So like on line 32, where I was separating out the fields by commas, well, now they would simply be carets. So not that hard, but it's something you have to pay attention to. So how many fields, what kind of data do the fields look like? what is separating them from each other. Sometimes it's spaces, although those aren't typically a good choice. Commas are often a good choice. The problem with commas is that sometimes your source data also has commas in it, and it makes it weird to parse. So sometimes you'll see people using funky characters just because they don't want to like if I use carrots as a separator, now I can put commas in my in the data, and not have those be detected as separators, but instead just actual commas in the data. I'll run that again just to prove that it works with the update. So same difference. Okay, that's reading a file and parsing the data out of it. So your challenge on the lab is to pay attention to how many fields there are, what's separating them, and what kind of data they are. Yeah. I got an error with year equals STO. I don't. Are you in Replit? There's a couple of people saying they're getting an error with that, but I'm not, so something's funny. Huh, well, it should work then. I don't know. Oh, did you change your source data? If you didn't, it will do that. So I bet you didn't change your source data. So go in and double check your .txt file and make sure you have all the fields in place. Is the first thing I would do. Just check that your source data is correct. Because if one of these lines is missing its year, then it probably would crash it. Yeah, so the includes, so here's my includes. Look at all those streams, by the way. But the terminate called means that there's something wrong probably in the source data is what I would guess. So we included IOStream, FStream, SStream, and string. String is where STOI comes from. I don't know. I probably have to actually, Tyler or Baby Doll, if you share your REPL with me, I can go look. Yeah, those look fine. Anyways, share your REPL with me and I'll go look real quick. So hopefully it's okay, Tyler, people are going to see your code. So Boyd Trollinger. Okay, yeah, we'll do that. So we're having what we're doing is we're diagnosing a crash. Okay, the source data looks good to me. The includes look good. Ah, I see it. It's right here. It's not where you'd think it was. But this get line on line 34, if you don't tell it to stop at the comma, it reads everything else, and then when the year comes along, there's nothing left to get. So I just did funny somehow. Anyway, I'll punch it into your code. So it's that get line for the rating has to now account for that extra field, so you have to put a comma in it. Okay, so that's good. So it's for both of you, it's the same thing? Okay, perfect. I'll run Tyler's, make sure. Yeah, okay, so all good. That's a tricky one. These are very, very difficult. I mean, it looks like a fairly straightforward piece of code, but A lot of moving parts. Okay, so that's file parsing. The one thing you're going to see, by the way, on the lab, I think I made myself a little, print movie function. So instead of this in your lab, it has a function, and I think I implemented it for you, I don't remember. But it has a function to print a movie, so your job is to open the file, read the file, parse the line, create the movie, and then send the movie on over for printing by the function, which should be the same output because it'll just print all four. Okay, good. So Baby Doll confirms that I did implement the printing for you. So once you've done all the parsing work and loaded up a struct with the data from the file, then print it. And of course you're repeating this process, so as many entries are in there, they should all just end up printing out in some formatted way. So that's kind of what Lab 5 looks like. Okay, I'm about to do a switch over to the command line arguments part. And I think I will, I'm going to move this code to the side for a second and kind of start over with less code to look at. So take a breather. It's going to take me 30 seconds or so to switch this over, but I'm going to make a notes file. And I'm going to copy all of this stuff. In fact, I'm going to cut it and put it in notes. Alright, so I'm setting that aside because I want to focus your attention on the second half of what we're learning this week. And the second half is command line arguments. Now, they're meant to work together, and I will show you in a second how we mean for these things to work together. But let me rebuild this. We don't need anything else to start. Let's just get the basics. Okay, so command line arguments. So this is kind of part 2 of making your life as a programmer easier in reality. I mean, once you get used to it, you're going to realize, oh, this makes life so much easier. I can just have my program read in a file and I don't have to sit there and do anything. I can just have the program process the file for itself and then watch what it outputs for me, and I don't have to answer questions or do menus or anything. So the first part of doing that is reading the data from a file. The second part is making programs a little bit flexible in terms of the files that they can read. So we're going to add something to main here, and it's going to look awful at first. But it's really not that big a deal. You just have to understand what it means. But this is another one of those, kind of the same way that when you're looping through the file's contents as you're reading it, it's not obvious how the reading is advancing through the file automatically. You have to understand that it does. So every time I do a get line, it moves forward somewhere. But it doesn't show that in the code. You just have to know that that's what get line does. It advances to the next thing. So this is kind of like that in that you can't see it at first until you've practiced with it. So notice what I've added here. So if you go Googling it, just Google argc, argv, and you'll find tons of stuff about argc, argv. These labels, argc and argv, don't have to be argc and argv. I mean, I could call this shoes and buckles if I wanted to. But if I went Googling shoes and buckles, no one's going to know anything about what I'm talking about. But if you use argc and argv, they'll know exactly what you're talking about because this is traditionally how we refer to these things. So what are they? Let's start with argc. We'll just start with this. Let's just look at argc and then I'll show you a trick about how to explore it better. So the whole point of what we're doing here, the reading the files is because it is so much easier to develop code if you can just take masses of data from a file and have it automatically processed into your program. Then you don't have to manually type the input to your program. You can just let the file give the input to your program. So this is another aspect of getting all the power out of the file reading, is to make it so that our programs, we can run our programs with different inputs without having to change the code, which is kind of our goal, is to change the data that's flowing into our program without having to change the actual code. So I'm going to run this, and it's going to say 1. This /main, by the way, is the program being run. And it says it received 1 argument. So what I'm going to do now is I'm actually going to type down here. So I'm going to type, but I'm going to say hello instead. Program received 2 arguments. 3 arguments. I'm using the up arrow key, by the way, to get the last thing I typed down here. 1, 2, 3, 6 arguments. So arguments, what argc is referring to is a count of the arguments that were included with the program being run. So the program itself, /main, that is 1 argument. That is the 1 piece of information that flowed into the program, and it was automatically counted. You may notice I didn't actually write any code that did anything. It just sort of automatically called that 1 argument. Automatically called /main space hello 2 arguments. Automatically counted 3 arguments. Automatically counted 6 arguments. So an argument is the program name itself, and then any additional information that's supplied when the program is launched. We call those arguments. Argc is the count of the arguments. So the count of the arguments is automatic. I don't have to do anything to get the count of the arguments. It's automatically created for me. So the system counts how many things are on the command line separated by spaces. So the program name itself is always 1, and then however many things follow it are 2, 3, 4, 5, 6, and on. That's what argc does. Okay, so what is argv? This looks funny, this char star, but all that is an old school string. So all this really is an array of strings. So in addition to counting how many pieces there are, the system actually puts them into an array for you, and the nice thing about that is that you can cycle through the array. I'm going to use something called a size t here. I better not do that, that's confusing. Not yet, not yet. Alright, so now what I'm going to do is I'm going to write a loop. This should look like a familiar, more or less, array processing loop. Argc, that's the number of elements, that's the number of arguments, but it also happens to be the number of elements in this argv array, because that argv array has all of the command line arguments in it. So I'm going to cycle through it and I'm going to print them. And I'm going to put little, just cute little characters. So we'll print out the I, and then I put a little space there, and then, so I'm going to cycle through this array, and I'm going to look to see what's in there, and I'm going to show the index values as I do it. Now I need to recompile the program now, so to do that in here I'm going to click Run. Okay, so here it is with just main. It counted one argument, and it put it in argv at index 0. So there's one argument, /main at argv 0. I'm going to use the arrow key to maybe. Oh, guess not. Got to type it. So now hello. So what we should anticipate is this is two arguments. Index 0 is main, index 1 is hello. Just as we expected. We'll run it with 3 arguments, and they're all 3 are coming out of that array. And then we'll do it with 6, just to show that that's... So all of that stuff, it looks like a terrible, terrible mess, but it's automatically created for you, and it has uses. That's the important part, is that it can be very, very useful. So hopefully that's okay for everybody. I'm actually going to comment out this for loop. I'll leave it there for documentation purposes, but I want to comment it out because I want to talk about using this, and then I'm going to go back over to my old movies file and show you how I would use it. Okay, so how would we use this? Well, sometimes what we would like, what I want my movie program to do is I want to be able to say, like, I want to be able to load different data files. So what would be awesome is, instead of having to actually code the file names into my program, I could just type them as I launch the program, and that would feed the file name into the program, and then I could open my horror movies file or my Disney movies file. So this is what I want. I want a program that allows me to say which movies file I want to use on the command line. So hopefully that makes a little bit of sense. This is what I want you to be able to do. You're going to create applications in this class where we, in evaluating your code, want to be able to feed different input files into it to see how it responds to them. So what we would love to have is a program that works like this. We do /main, and then we provide it with a file name. And then it automatically knows to go open that file and process the data from that file. So to do that, we need to be able to read files, of course, but we also need to be able to take that data from the command line and use it in our programs. So I'm going to comment out this one too. So what would that look like? So I'll just sort of talk you through how the thought process here. What I want is, I want the program to be run with 2 arguments. The program name itself is always 1, and then a second argument that is a file that has movie data in it. That's what I want. So the first thing to do when you're handling command line arguments is to be paranoid and assume that they screwed up. So what happens, I have to imagine right now, what would happen if they ran the program with no file? Well, if they don't give me a file that I can feed into my program and then open and then process, I don't really want the program to run. So I'm going to write a little bit of paranoia logic here to detect that situation. And the situation that would be a problem for me is if they don't give me exactly 2 arguments. If they don't give me exactly 2 arguments, I have to assume that they didn't understand that I need the program name and a file name to go open. So if I don't get exactly 2 arguments, I'm going to say something about it. And what we typically do is we provide some kind of a usage message. So this is a little bit of a hey dummy kind of message, but if you don't give me 2 arguments, I'm going to remind you how this works. I'm actually going to take the program name straight out of argv0. So that program name you typed, followed by a file name. So this is error handling. If they don't give me the 2 arguments that I need, which is the program name and a file name with movie stuff in it, then I'm going to print a message to them telling them that I need that stuff. So yeah, the program name's fine, but you need to give me a file name. In fact, we can just run that and watch. So I'm going to run it. So notice it's going to say, you can't just run it. You need to run it with stuff in it. All right, so what about Disney movies.txt? Okay, it's perfectly happy now. It's not doing anything, but it's happy. So now the else part. So if I get exactly 2 arguments, which would get me in this else part, well, I already know that argv0 is always the program name. It's always one argument, and it's always the program name. But I know that the second argument, which is argv1, should be the file name. So for now, I'm just going to say, hey, okay, you gave me a file name. I will open and process it for you. I need to click run to compile this because I changed the code. I'm going to get an error, but now I can say Disney movies.txt, and the program knows, oh, this is the point where I am supposed to open a file and do stuff with it. So that's the command line arguments part. The documentation should tell you to do something if you don't get the arguments that you need. In our case, we need exactly 2. One is the program name itself. The second is the file name that we want. So let's go now change our actual sample program to have this stuff. And in fact, let's just, no, I'll rewrite it. I'll rewrite it, it's fine. So let me go get notes. In fact, I'm going to make a new one called notes 2. And I'm going to move this little sample into it. And then I'm going to go grab my original notes, not cutting this time, no copying. Okay, so now let's incorporate. Let's incorporate the arguments into this bigger program. So what I want you to see is what we're trying to get rid of. This line right here, if I leave movies.txt hard-coded, then this program will never work for other movie files. It's hard-coded to one exact movie file, and it doesn't give me the option of like separating out my Disney movies from my horror movies, from my Woody Allen movies, or whatever it is. I would have not that option to do that. So, to make this a much more powerful program, I'm going to introduce command line arguments. And now I can not have to move something. Now I don't have to hard code movies, so I now have a much more powerful and flexible program after I've added the logic. So we'll use the same logic. If the count of arguments that I get is not exactly 2, then I'm going to say something about it. That program name you typed, followed by a file name. All right, be careful on this next part if you're typing along with me, because I need to open up an else that covers all of the rest of this stuff. So all of the rest of this stuff all the way down to here. So I tap that over, and then I'm going to close this else right here, which it doesn't highlight. Oh, there it highlights it. So if I fold this, can you fold? Yeah, you can. If I fold this, notice everything else about the program is in there. Everything else. So if I don't get the arguments that I want, I just print out an error message. Otherwise, I can act on it. So I don't want to use hard-coded movies anymore. I want to use argv1 as the file name. And that's it. I'm having a failed to connect. So it makes me unhappy. Did that keep my work? It did. Okay. So hopefully everyone kind of followed that. The folding can help, by the way, to make sure that you have everybody where they're supposed to be. So notice inside this else is where I attempt to open a file. So given that I have a file name, now I can try to open it. But even though they put a file name, that doesn't guarantee that it's there still. You gave me a name, but it's not there. And I'm going to change one other thing, which is it's not guaranteed to be called movies.txt anymore. It is whatever they put in as argv1. So let me unfold so you can see the whole thing. That's way down here. So instead of saying movies.txt, I can actually say whatever that file name was that you gave me, I couldn't open it. All right, so let's run this. We're going to get an error. It's not an error. It's the program saying, I need a file name now. Okay, so I'm going to make one up called not here. So I shouldn't get the usage message because I have given it a file name, but it doesn't exist, so it won't open it. So yeah, you gave me a file name, but I can't open that. And now if I give it the movies file, it loads it. And let's make another movies just for fun. Call it new movies. Or old movies. We'll do old movies. And then I'll put some old movies in there like Casablanca. I don't know what you call that. Suspense. Pretty high rating. And the year is 1940 what? Like 44 or something. That's fairly old. Annie Hall is comedy. Because I said Woody Allen at some point, 4.4, 6, 7. That's something like 1977 or something like that. Anyway. Oh, Nosferatu. That's good. That's good. That's horror. Let's go all the way. And that's like 19, who knows, 32 or something like that. 22. Wow. Okay. So do you see I have a movies file and I have an old movies file. I don't have to change my program. I changed no code. All I have to do is say, actually, let's look at the old movies. Except for it crashed. What did I do wrong? Oh. Yes. Thank you, Glazer. Yeah, I use commas in here, but the format requires... Now, if you're clever, you might be able to figure out a way to sort of parameterize this inside of your code, but that's correct. They're supposed to be carets. So one thing you might know here is the first place, and Glazer caught it real quick. First place to look is your source data when you get a crash, and just see if the source data is broken somewhere, and then look at your parsing code. Oh, yeah. Well, I didn't have to recompile because I only changed the source data, but now let's do old movies. So there they are, and then I can do the original movies, and there they are. So I know it's awkward feeling at first because these are new ideas and the code looks a little bit hairy for it, but it's so powerful. It makes your life so much easier as a programmer because you don't have to think much about data anymore. You just sort of, you whip up some file processing code and then you set it aside, and then you can just sort of make gigantic files of input data, and then you worry about the interesting stuff, which is the algorithm. The algorithms underneath that do things with the data. So we're not actually doing anything with the data here. We're reading it from a file. We are parsing it. We are loading up an instance of a struct with the parsed data, and then we're printing out the instance of the struct that now contains the parsed data. But then we added command line arguments, which allows us to put input data in different files and then just run the program without having to change the code with different input data. So that's sort of the cool thing. Okay, I think I gotta stop. I do. So thanks for sticking around if you stuck around all this time. Thanks for your help on the debugging, and thanks for sharing when you did have a bug, because that's very useful to go and see if you can unravel a bug in one's code. So we did reading file inputs, parsing input. We did command line arguments, and I also talked to kind of encourage you to go look at c++.com. And it takes a little bit of practice to read this stuff. I'll be doing it more as the semester goes on. But have a look in there, because if it's standard libraries in C++, you're totally allowed to use it. So with one exception, which is the linked list stuff. But in most cases, you can just use it. Down at the bottom here, by the way, there's a few. There's string to float, string to long double, string to integer, string to float. There's others. Anyway, so look around. If you find something interesting, if you're ever in doubt, just put it in Piazza and I can tell you if it's legal or not for our class. But like as not, if you find it in c++.com, you're totally allowed to use it. Okay, I think that's it. Thanks for being here. I hope you all have a good week. Get on Piazza if you have questions about the projects. I monitor them every day, and some of your classmates do as well. Rock starring it, some of your classmates. So anyway, good luck. I'll check Piazza every day. I'll check Canvas inbox every day. So hopefully things go smoothly for you for the rest of the week. Thanks, Tyler. Appreciate it. Yeah, agreed, little peeper. Everybody have a great night and a great rest of the week, and I will see you on Tuesday next week.